Hi, Algebra 2. Welcome to our homeschool for Algebra 2. So for the next little while, we'll be doing this at home together. So this will be a Zoom meeting that I put up for you all so you can watch it throughout the week. I've actually done the entire Zoom lesson and realized that I forgot to press save. So you're probably seeing the end up on the board. So this is take 2. So hopefully this will all work out. So now that I've had my practice, we should be able to truly Zoom through our lessons today. Just to kind of let you know a little bit about the procedures that we're going to be doing. We are scheduled to have 6 more weeks of classes. And in those 6 weeks of classes, we will continue in the same manner of doing 4 lessons a week. And you will have your online assessments. Now you can't turn in to me your notebooks, so you'll need to give those to a parent at home and have them check. As an added bonus to you guys, I would like to offer you that you can do the odd for your work, just so that since we won't be face-to-face and able to interact as much, I want you all to have that added bonus that you can check it in the back of your book. Now, please remember, that doesn't mean that you can copy the answers from the back. Your parents should still see your effort and your work. So please make sure that you're taking the time to do that, because your final exam will be on the 6th week. And if we're not able to do that as a paper exam face-to-face, then I'll do that as an online exam. So please make sure that you're working on these problems and practicing them at home. So we are going to go through our lessons, and then we'll do a Zoom class together to go over any discussion, any additional review that you might have. And I want to just put one more plug in to please reach out. If in doubt, send me a text, send me an email, send me a notice on Schoology so I can put up a discussion board, or we can meet in a Zoom class throughout the week to help some of you all who may be struggling. Because you may be homebound, but technology is great. So we're going to be able to work together. Forgive me because I'm going to work backwards. I have already done lessons 104 to 107 and then realized I forgot to make it so it recorded. So when I went to put it on our channel, I realized that it was not saved to my laptop. So back behind me, I have all of lesson 107. So I'm going to walk you through it step by step, so that way I don't have to erase it. I think I might cry over beautiful math that doesn't get to be shared, right? So I know you all probably will not cry about that at home, will you? All right. I'm excited to be able to at least use this technology and for us to be able to still have math fun at home. I think the only area that I was a little bit concerned about was you all won't get to enjoy brain food while we teach algebra together. So I thought about eating some brain food while I taught you, but I thought that might be a little bit unfair and unkind. So I'll save up your brain food and hopefully we'll get to see each other soon face to face. All right, so lesson 107. So this week you'll be doing lesson 104 to 107. And I know that mathematically it's not fair to go out of order, but I appreciate you all being patient and doing that so I don't have to erase it. But 107 talks a lot about numbers and their values. And lesson 107 is word problems. I know when we hear those word problems, sometimes we panic and think, how do I set these up? But don't panic. Just remember that as long as we can get it into an algebra problem, then we can solve it for our unknown. Well, in lesson 107, and it's practice A, it reads on page 441, the sum of the digits of a 2-digit counting number was 7. All right, so let's start right there. So it tells us that the sum of the digits. So we know that I have to take these 2 digits. Now, forgive me because I already have the answers up here. So I'm actually going to go ahead and erase the answers. And I know you guys probably already peeked, so you know it. But let's talk about it. It says the original number. So we know that it was the tens and the ones place. But then it said, so we know that together it had to add to make 7. So the original number, the tens plus the units, would make 7. Now, the book then tells us, it says when the digits were reversed. So the units would be multiplied by 10, and the tens would become the units. So that would be the reversal of the two. So the book says, when the digits were reversed, the new number was 27 less than the original number. What's the number? So what we did is we just took that, we first made one equation with the tens and the units made 7. That's our first equation. Now our second equation, we just took the whole last sentence and made an equation. When the digits were reversed, so here's where they were reversed. The units became the tens and the tens became the ones, right? So when the digits were reversed, it says the new number was 27 less than the original number. So in order to set them equivalent to each other, I have to take the reverse number and I have to take the original and subtract it from 27 to make them equal or equivalent. So the dilemma is that I have two unknowns, units and tens and units. So what we did is we took the first equation and we isolated u. We're going to substitute u. So what I did is I subtracted t from both sides. So I got my units equals 7 minus my tens, or my t. So forgive me because I've also done the work there to solve it, so I apologize. But what I'm doing is I'm going to substitute this now in for the u. So that's what we did here, t minus 7, and we substituted it in for the u. So each place you'll see this was substituted in. Now what we're going to do is rewrite it. So I have this equation, but I'm rewriting it so that I have only one variable, my variable t, because I've substituted that in for the u. So now what we did is distribute, because it was 10 times 7 minus t. So I distribute that 10 to both. So I end up with 70 minus 10t plus t equals, and I'm again just showing where I've substituted that in. Now I have eliminated all u's, so what I have to do is get my variables together. So I owe 10t, but I have 1t. That means I owe more than I have, right? But over here I have more than I owe, so I end up with 9t over here. Now please be very careful to make sure that you're watching your signs, because this is a positive 9. That means I need to subtract 9 to bring it to the other side. So that means that I have a negative 9t and another negative 9t. Those don't cancel out. They're the same. I'm doubling it. So I owe 18t. Now I bring the 70 over to the other side. So if I owe 20 and I owe 70, that leaves me with owing 90. So I have negative 18t equals negative 90. I divide through by negative 18. All my negatives canceled out so beautifully, and it leaves me with my tens is 5. So if my tens is 5, I plug that in up here. 7 minus 5 is 2. So my units would now be 2. So I know that my original number would be 5 tens and 2 units. So it would be my original number, 52. Now the reversal of that would be 25. Well, if I subtract those two numbers, I do get 27. So we can verify and make sure that I have solved that number word problem correctly. So it's all about making sure I keep the value of the number, the tens place, the units. And then again, if I have two unknowns, I have to solve it in terms of one. So that's where my substitution comes into play. So thank you for allowing me to start with lesson 107, just because that was a full problem, and I already have videoed this once and accidentally did not save it correctly. So I do appreciate us working backwards. Now let's jump back to lesson 104. So we've done lesson 107. We've looked at word problems and their values. All right. So they're time consuming. They're a little bit tedious, but they're not difficult. It's just watching the value. Now let's take a look at lesson 104. Lesson 104 reminds us about complex numbers. So complex numbers, we have our real part first, then our imaginary. Then they talk to us about what a counting number or a whole number or an integer. All those terms are very important, and you'll find those on page 429 of your Saxon Algebra 2 3rd edition. All right. Now, your book on page 430 reminds us of what a rational and an irrational number is. So we remember that a rational number is anything that can be written as a fraction. So 1/2, 1/3, those are rational. The difference of 1/2 and 1/3, 1/2 is 0.5. We call that a terminating decimal, right? I'm gonna move to my black because I think you might be able to see that better. And then 1/3 is 0.3 repeating. That 3 never stops, right? We call that a repeating decimal. So there's a little bit difference there between a terminating and a repeating, but both are rational because they can be written as a fraction. What's an irrational number? Well, an irrational number, your book gives you an example, is the square root of 2. Because it's not a perfect square root, it's neither going to terminate or repeat. Therefore, this is irrational. So these we call rational, and this would be irrational. All right, so just to kind of remind you the difference of that. Pi is also another example of an irrational number because it neither terminates nor repeats. All right, now your book is showing you how can I take a decimal and turn it into a fraction to know that it is a rational number. So you all know just basic numbers, like we did 1/2, 0.5 is 1/2. But your book is showing you much more difficult fractions. On page 430, they give you an example, and they show you multiply it times 10 to the 8th to solve it. Well, the interesting thing is our practice problem, practice A, on page 432, we're on practice A. All right, and it is 0.0000513. So they give us that decimal, and there is 1, 2, 3, 4, 5 zeros, and then 513. So I've got to rewrite that as a fraction to show that it is a rational number. Well, I just take the non-zero digits that are right here, so it'd be 513 over, and I count out how many places I moved it over. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to write 6, 7, 8 zeros. So this is my answer. So it's 513 over 100 million. How did I get that? Because I knew I had to move it 8 places. Now your book actually shows where it takes this numerator and it says that it's multiplying it times 10 to the 8th times 10 to the 8th. But you all understand that 10 to the 8th is 100 million because it has 8 zeros. So you don't have to take the time the way the book worked it out. They're just visualizing to show you. So as long as whatever you do to one, you do to the other. I moved it over 8 places, so I moved my denominator over 8 places, 8 zeros. All right, practice B is a little bit more difficult. So practice B, they're, instead of giving us a terminating decimal, they're giving us a repeating decimal. So on practice B, they've given us 0.01524, and the 24 repeats. All right, so what I need to do is I have to make 2 equations so that I can eliminate and solve, because I've got to rewrite this. So what I would do is say 1 in one of these numbers is 0.01524. Now what I need to do is move it over so that I can see where that will terminate. You all see that, excuse me, it's not terminating, it's repeating. But the difficult thing is I can't just write this 1, 2, 3, 4, 5. I can't just move it over 5 decimal places because the 2424 repeats, it never ends. So what I'm going to do is write another equation so I can subtract them from each other to get the terminating part to eliminate, right? So if I move this over 2 places, I would have 100 in equals, and I moved it over 2 places. So that would give me 1.52424, and you can see that 24 is going to repeat. So what I've done is I've canceled out this repeating part. So what I can do is subtract these 2. right? So I have 100n and I'm going to subtract 1n from it. So you can grab your calculators, 100n minus 1n. If you want to rewrite it so that you can see the larger on top, that's fine. But I'm subtracting the smaller from the larger. So that would give me 99n equals 1 point, and I'm working backwards. So I know I would borrow from this. 14 minus 5 would be 9. And let's see. So I end up, let me grab, I've actually done the work before I came on. So it ends up being 1.509. All right, because I have borrowed there. All right. So if I have 1.509 and I've got 99, I'm going to divide it by 99, right? So I end up with my number is now 1.509 over 99. Now, this looks a little bit odd because even though I have this written out as a fraction, and remember that in order to be rational, it has to be able to be written as a fraction. But my dilemma here is that I have a decimal place, and I should never have a decimal place with what I'm solving, right? So the dilemma there is that I've got to get rid of the decimal. So how do I do that? Well, in order to do that, I just move it over 1, 2, 3. So I'm going to annex 1, 2, 3. So my final answer, 1,509 over 99,000. All right, I hope that that makes logical sense to you guys because I'm having to solve. Here's where I made my mistake. I borrowed from the 2 and made it a 1. So I just caught that. I just kept thinking there's something wrong on that board because I borrowed from the 2 and made it a 0. So I apologize. Even math teachers can make quick errors, so always check yourself. Those small errors are what can cost you the wrong problem. So my final answer. Now, one thing I want to encourage you is I always verify because it's easy, just as I pointed out, to make a mistake. So grab your calculator and divide 1,509 divided by 99,000. And your calculator will show you that that 2424 keeps on repeating and you did get the right answer. So if you did something wrong, that's the great part about math is always logical. It has to make sense. So always verify and check that. So we have just done practice A and practice B for lesson 104. Now let's move on to lesson 105. So we've done 2 lessons and we've got 2 to go. Now lesson 105 is advanced factoring. Now the difference between advanced factoring and regular factoring is we're going to have a little bit more legwork that we have to take care of because my leading coefficient in these cases are not going to be 1. So it's going to require us to do a little extra work. I would encourage you to look over how Saxon does it. They start on page 433 and they continue on through 436 where the practice problems begin. So I would encourage you to look over those and see if you have any questions. They set it up a little bit differently. I like to organize my information so that I can see how my numbers fall and where the signs go to work with that. So let's spend a little bit of time. So we're on lesson 105 and we're on practice A. All right, so the problem that they give me is negative 5x minus 12 plus 2x squared equals 0. Now, we can tell immediately that this is not written in proper order because it should be descending. My x squared gets to go first. 2x squared minus 5x minus 12 equals 0. Now it's proper. X squared to the first constant, and I have it set up correctly. Now, my leading coefficient always needs to be positive. In order to follow my rules of factoring, this is positive, so I can continue. Unfortunately, if this were even, I could factor out a 2 in common, but since that middle term's not even, that's what makes this advanced factoring. Now, I can come down, and I can remember to set it all equal to 0, and I can go ahead and set up my brackets. Now, this tells me I look at my last sign first. Remember, the last shall be first. So I look at that last sign first. Because it's negative, it tells me that these signs are going to be different. I can go ahead and break apart my x's, but I don't know which one will have which leading coefficient of 2, and one will need to be 1. Since one's positive and one's negative, I can't write that in. If they were the same, I could. So what I've got to do is look at my first factor of 2, which would be 1 times 2, since that's a prime number. 12 is a little bit different. So because it's 12, it could be 1 times 12, it could be 2 times 6, and it could also be 3 times 4. Notice I went in order, 1, 2, 3, it meets at 4, so I know those are all the factors. So I have to think through, what are the factors of 2 and 12 that when multiplied together, because they're different, they subtract to make 5. So I need a negative 5. So if I have the first factor is, it has to be 2 and 1, or you could write 1 and 2, it doesn't matter which way. Now, if I go ahead and put my last as 1 and 12, if I multiply that together, that's going to give me 2 and 12, because 2 times 1 is 2, 1 times 12 is 12, 2 minus 12 is negative 10, I need negative 5. If I switch those two, that would give me 24 minus 1. So 12 and 1 is way too big. I know those are not the correct factors. So let's take a look at 2 and 6. So if I have 2 and 6, 2 times 2 is 4, 4 minus 6 is negative 2. That won't work. Let's make it go the opposite. So let's switch 6 and 2. So we'll put 6 here and 2 here. So 2 times 6 is 12, 1 times 2 is 2, 12 minus 2 is 10, I need 5. So I have now eliminated 2 different sets. So I know the last factor has to be 3 and 4. I just have to figure out which way it goes. So if I have 3 here and 4 here, 2 times 3 is 6, 6 minus 4 is 2, I need 5. So that's not correct. So what do? I've got to switch them, 4 and 3. 2 times 4 is 8, 1 times 3 is 3. Friends, 8 minus 3 is finally 5. Last time I finally got it, right? All right, you might wonder if I did that on purpose. I just wanted you to practice. All right, so 8 minus 5, or excuse me, 8 minus 3 is 5. So notice that it's a negative 5. So I need the 8 to be negative, the 3 to be positive to give me negative 5. So if the 8 needs to be negative, that means that 4 needs to be negative. Now, the other last one is 3, because here are my last. 4 and 3 make 12. 4 and 3 make 12. So that's where those come from. Now, one thing I want to point out to you is opposites go in the same grouping symbol together. So 3 would go with the 2. 1 would go with the negative 4, because they're opposite each other. If you put the 4 and the 2 in the same grouping, they wouldn't get multiplied together, and I need them to get multiplied together. So look for those opposite groupings. One of my students pointed that out to me. So that is definitely an added help and a reminder. Now, always FOIL to check to make sure. Nothing's worse than doing all this work, figuring out the right, and then plugging them in wrong. So make sure you FOIL to check. So I'm going to FOIL first, outer, inner, and last. And all I'm doing this for is to check. So first, 2x squared. Outer, negative 8x. Inner, plus 3x. Last, minus 12. These two combine together and make negative 5x. And I have the correct answer. I'm going to erase this. I was only FOILing to check to verify that I have the right answer. Now, some of you may stop and say, well, I've got the right answer, I'm done. But your question asks you to solve. So we have factored, we have one step further to go. So let's separate this. 2x plus 3 equals 0. 1x minus 4 equals 0. I'm going to solve it. So 2x equals negative 3, divide through by 2. X equals negative 3 halves. This time I'm going to add 4. Remember, I'm always doing the inverse operation. So x equals 4, x equals negative 3 halves. I've solved both. I FOILed to check to verify, and I have the correct answer. So I'm finished. That's practice letter A. Now let's take a look at practice letter B. Now I would love for you to try to set this up on your own, So maybe at home you could pause this video and try to set it up yourself, and then unpause it and see if you worked it correctly with me. All right, so letter B is where we're at right now. So negative 7x minus 6 equals negative 3x squared. All right, again, this is the wrong format. I need to bring over, so I'm going to add 3x squared. Add 3x squared. That will leave me with 0 on this side, and 3x squared minus 7x minus 6 equals 0. Now I have it set up correctly. So that will help us in solving this. So I have it set up in proper order. My leading coefficient is positive, and I always need to have that. Now, since my leading coefficient is positive, I do want to always remind you, check to see if there's anything in common. If you could take that 3 out, it would make factoring a lot easier. Unfortunately, 7's not divisible by 3, so again, here we come, advanced factoring. We're ready. All right, so I'm going to go ahead and put my brackets, and I'm going to notice my leading coefficient is positive, so I look at the last. My last sign tells me again that they are different, and they have to subtract to make negative 7 because they're different. So my first, since it's 3, would just be 1 times 3. It has to be because it's prime. Now, my last number is 6. So it's not prime, but at least it doesn't have as many as our practice A does. So there's only 2 different options, right? So I've got to look at my first and my last. I know 1 times 3, but now I need to decide is 1 times 6. Now, if I put 1 times 6, 1 times 1 is 1, and 6 times 3 is 18. If I subtracted those, that's negative 17. That's way too big. If I flip it, it's just going to give me 6 minus 3 is 3. So I've already eliminated just by doing that in my head. It can't be 1 and 6. So I know it has to be 2 and 3. I just have to decide which way does it go. So 2 and 3. All right, I just put it in that order. 1 times 2 is 2. 3 times 3 is 9. 2 minus 9 equals negative 7. So we found it simply by plugging in. And this little bit of scratch work right here will be a great friend to you. So make sure that you're taking the time to work that out. I've seen some students before where they'll just keep putting in numbers and they keep erasing it. Sometimes they'll get holes in their paper because they've turned it around so many times. So I love this little scratch work area, and this is how I set it up. So I organized the first and the last. Now, it has to be a negative 7, so the 9 has to be negative. So that means my last has to go with negative 3. All right? And the other last one was 2. Now, don't forget the opposites go in the grouping symbols together. So opposite are in the same grouping with the 2 needs to go the 3x, and x goes here. All right. Just remember the 3 and the 3 have to get multiplied together to be 9. They can't be in the same grouping together. I need 3 times 3 to make 9. If the 3 were here, they wouldn't get multiplied together. Now, FOIL to check. 3x squared minus 9x plus 2x minus 6. And this together makes negative 7x, so we have the correct answer. I was simply foiling to check to make sure we did it correctly. Always, always take those few seconds to verify. All right, I'm not finished though, because friends, remember it said solve. So we did factor, but it said solve by factoring. So break these apart and set them equal to your 0. X minus 3 equals 0. I'm going to add 3 to this side over here, so x equals 3. I'm going to subtract 2. And get 3x equals negative 2, divide through by 3. I'm always doing the inverse operation to get my variable by itself. So here's my 2 answers. So x equals negative 2/3 and x equals 3. I've solved both of those. All right, so we have officially done 3 out of the 4 lessons. Our last one is lesson 106. Now, you can tell this week that our lessons aren't anything that is a completely new concept. It's just digging deeper in some of the things we've already done, factoring, and just getting more into more difficult factoring. So if you have issues this week, please reach out and let me know. So if you need some additional Saxon practice problems put online, or if you'd like me to meet you in a Zoom lesson just to go over a few of those, I'd be glad to. So lesson 106 is more on systems of equations. Now, we have solved these in class before where we're solving for x, y, and z. And we know that it takes a lot of manipulation and trying to get those x's and y's to cancel out so we can get one unknown and to solve it. Well, in lesson 106, it's a little more advanced because they're giving you equations that every single one of them don't have the exact same variables in it. So that's where it gets a little bit more tricky. So let's take a few moments to review not this new concept, but just to review over it in just a little bit different light. So I'm looking on page 438. We're on our last lesson, lesson 106. Don't forget, you'll also do lesson 107. We just started with it first today. So our only practice is on page 438. So I've got 3x plus 2y, and I'm going to leave a space equals 6 because there is no z. All right, the next one is 2x minus z equals 9. And then I've got 3y minus z equals 10. All right, so they've given me these three equations. Notice each one only has two variables. So this one doesn't have a z, this one doesn't have a y, and this one doesn't have an x. So I left it that way so you could see the gaps and kind of understand that there's a way that I need to solve this, right? So, so when I'm looking through, I realize I've got to isolate some variables. Now, what if I combine these two equations and I got rid of the z so that I could have a similar equation to the top one so that I could eliminate another variable? That's a lot of do this and then do this, right? So we have to kind of think through, how can I get this to work? Now, the dilemma here is they're both negative. So if I add them together, I'll just have negative 2z. So I've got to multiply one through by a negative to get them to cancel. So I'm just going to take this first equation and say multiply everything through by a negative. So I'm going to change every one of those signs. Negative 2x plus z equals negative 9. So I took this second equation, multiplied through by a negative. Now what I'm going to do is I'm going to combine together these two. So if I add these two together, I have negative 2x plus 3y. The z's canceled and left me with 1. So now I have an equation that looks similar to my top with no z. So what do I do with that? Well, I'm going to bring down this equation. 3x plus 2y equals 6. Here's another dilemma because none of those cancel out nicely. But since the x is negative and this one's positive, what I'm going to do is multiply this by positive 3, this by positive 2, and that's going to give me negative 6, positive 6, and those x's will cancel out, and I'm left with my y. So that's going to be beautiful, right? So how do I set this up? Well, I'll just rewrite it here. So I've got negative 6x plus 9y equals 3. And I do want to remind you guys, please make sure that you don't forget to distribute it to all. And then here, 6x plus 4y Okay, I apologize. I hope that you've been able to follow. It just told me that I was temporarily muted, so I hope you're still following along with me. So the dilemma here is I end up with just one y, so I've got to solve for that. So if I divide through by 13, I end up with y equals 15 over 13. Now, sometimes we think, oh, it should have worked out and given me a whole number, but you know that Saxon always wants to make sure you know what you know. So we're very thankful for that. So they solved it for y. So I can plug it back into any of these to solve for. So I can go back to this original first equation. And I can say 3x plus 2, and it would be 15 over 13 equals 6. All right, so then I would solve 3x plus 30 over 13 equals 6. All right, so I'm going to subtract 30 over 13. Now I can convert 6, that is equivalent. If I multiply it times 13, that gives me 81. Is that right? No, that's not correct. All right, 6 times 3 is 18, carry my 1, 6. So it should be 78. So this canceled out and I've got 3x equals, and it should be 48 over 13. So I'm going to divide through by 3. So you can do that on your calculator. So x ends up equaling, let me see if I can grab it. Hopefully you guys are plugging that into your calculator at home. All right, so I've got 48 thirteenths divided by 3. So my answer there is x equals 16 over 13. So 16 over 13 is my x. All right, so I figured out my x and my y. Now I can plug it back in and figure out my z. I'm not going to take the time to do that. I've got just a little bit of space left. But you all can see that if it's over 13, I will give you a hint that z does end up with a denominator of 13. So hopefully that will give you an opportunity to just understand that even if I'm missing parts of my variables, like if here I was missing a z or a y, you still have to make sure that you have equations that you can isolate one variable. So we've done it before where we had 3 equations and all 3 of them had x, y, and z. And it still takes a little bit of time. I think it would have been a little bit easier if they had worked out to be whole numbers, but at least you know you're on the right track if you end up with a denominator of 13. All right, so great job. And this week, don't forget, you'll be doing lessons 104, 105, 106, and 107. And we've done the practice problems for those. So please stay tuned. We'll have a Zoom meeting today to discuss any questions you might have or anything you'd like to review additionally that we've gone over before. So I'm looking forward to seeing you guys in a week. Don't forget to do your online assessment this week, and you'll also tell me if you have completed all of your homework, and that's where I'll be getting your grades from, since you won't be able to give me a physical notebook for this time. Thank you guys so much, and I'll see you soon.